All right, I believe this is the fourth video, and we are at the top of page 323, and we are looking at the triangle mid-segment theorem. It is truly just building on what we just proved, basically. There it is. And over here it says a mid-segment of a triangle is parallel to a side of the triangle, and its length is half the length of that side. So what that's saying is a mid-segment of a triangle is parallel to a side of that triangle, the side below it or above it if it's an upside down triangle, or to the side of it if it's turned sideways. And that mid-segment is half the length of that side. So that's exactly what we've done in the last two problems. Notice why this is equal to this. It's because a mid-segment is built on midpoints. So this midpoint makes those two line segments congruent. Same with E, it makes these two line segments congruent. All right, using the triangle mid-segment theorem. This is always the fun part where we really just get to put the puzzle pieces together. So we want to use all that we've learned and find UW. Let's go over here and look at UW. UW is this line right here. Well, as you might can notice, it is a mid-segment on this side because that's equal to that. It's a midpoint. On this side, it's also a midpoint because that's equal to that. Therefore, this UW is a mid-segment. That means it's going to be parallel to ST. It also means, according to the theorem, that it's going to be half of ST. So we want to know what UW is. So if we look down here, this is the information that we need. ST is 7.4. We've got to break 7.4 in half to find the measure of UW, and 7.4 divided by 2 is 3.7. So all we did is we said, yes, this is half of this. Let's do the math to show it. Okay, the next one says, find the measure of angle SVU. Come over here and let's look for angle SVU. Okay, so looking at this problem, if you will remember, we're dealing with parallel lines. The mid-segment is always going to be parallel to that side that coordinates with it. If we have two parallel lines and they are crossed by a transversal, then we have just created some alternate interior angles and lots of other types of angles. So we want to solve for this angle right here. Well, this angle in the top corner is 41 degrees. According to our theorem that says when two parallel lines are crossed by a transversal, alternate interior angles are congruent. That means this angle must be 41 degrees. Okay, so that's the end of that answer. Now let's